There's a gap in the pharmaceutical industry for visual inspection of difficult to inspect products. These products have challenging primary containers such as molded glass, amber glass, and translucent plastic. And they also contain challenging pharmaceutical products such as powders, freeze-dried products, and also cloudy liquids. Traditional high-speed inspection machines are difficult to qualify, and they generally cannot be used for these types of difficult to inspect products. Unfortunately, reverting to human visual inspection produces inconsistent results, and it's slow and expensive. Avis fills this gap with an AI-based solution that fully automates inspection by learning the normal variation in the compliant products rolling off your production line every day, even difficult to inspect products. One day and 3 simple steps is all that Avis needs to train a recipe that's ready for validation and production. Let's use Avis to train a recipe for this difficult to inspect product, which has molded glass and a powdery active pharmaceutical ingredient. So there are 3 steps in creating a recipe for Avis. Step 1 is to create the recording of 500 compliant units. Step 2 is to actually train the recipe using our unsupervised machine learning approach. And then third, we go through qualification, which would look like a batch run at that point. So we click on Create a Recording from the Avis HMI, and the first thing we see is a view of the P camera, the product camera. We'll start the conveyor and bring a few vials into view of the camera so that we can adjust the optical settings. So you can see here, we're setting the exposure, we can set the camera gain, we can set the intensity, and this is a routine step for anybody who's familiar with computer vision. Finally, we want to save this camera setting so we have it later on if we want to run the same product again. We give it a name, which I'll just type in here as Demo 1 for the purposes of the demonstration here, and I hit Save. And then I finally hit Start Recording and start the conveyor, and the units start to move in front of the cameras. The P, S, and the T camera, each one is recording its own series of images at 30 frames per second of the vials as they pass in front of the cameras. Now, I'm not showing you all 500 units here, but having passed through the 500 images, now we'll give a name to the recording that we'll use in step 2 when we train a recipe. In step 2, we train a recipe using the recording that we just made. So we start our process by clicking on Start Training, one of the buttons in the center of the HMI here. And we now select the recording of compliant vials that we've already made. This recording is 3 separate recordings. It's the P camera, the S camera, and the T camera. And as you see the vial moving into the field of view, we can advance it and rewind it. And what we're trying to do is bring each vial into the area of the field of view where it will first be tracked by the computer vision system. We start with these blue lines here. These are really defining for the computer vision system where the vial is and what it looks like. And this is so it can distinguish it from a pocket or a roller, and it knows where to start tracking. The yellow line at the right says where it's going to exit the field of view. And then we'll do the same for the S camera. The T camera. Okay, so there we have our 3 definitions for where the vials are. Okay, the next thing we need to do is we need to place regions of interest or inspection cells on each vial, and each one of these inspection cells will be associated with a unique machine learning model describing what normal variation looks like within that particular region of interest. And so this one right here, as I click on it, you can see there's lots and lots of settings here. The good news is for all these settings, you can pretty much just take the defaults For some of the more sophisticated things that you may want to do, those things can be also done here. So for example, the blob threshold allows you to define the size of a particle that you may want to detect or allow. I'm placing a separate cell here on the cap in the skirt area. Because it's different from region of interest 1, it needs its own inspection cell. And so this is something that you'll learn by experience, but I think you can see the general principle here. We're trying to put discrete inspection cells on areas of the vial that have their own idiosyncrasies. Here we see a third inspection cell we're placing on here, and what I'm going to do is actually overlap that a little bit with cell 2 so that we have this 100% coverage. And then here I'll put another one on just for good measure. And this will be inspecting the shoulder area and then connecting down into the sidewall area. Let's put one more here at the base. And this is a pretty typical thing that we do down at the area wherever the fill line is. If it's liquid, it may be near the top. In this case, it's powder, it's near the bottom. And so it's going to learn normal variation in that fill line so that it can detect when something non-compliant comes through. Sometimes you may put a cell down in the mirror area, something like this, and this allows you to detect sometimes particulate matter just sits in the bottom. For this particular vial, we won't do that. It's a powder, and there's not much to see down there. Okay, now we're going to go back to the recording. So this recording comes up immediately after we click Start Train. And what you can see is these vials moving in front of the camera that happened during the recording. And the very first thing that we do is we're creating a tracking model. So that tracking model is part of the recipe where Avis knows how fast is that vial supposed to be running when the machine is running. And this is an important part of the recipe because when a vial gets qualified, it gets qualified for inspection at a certain speed. So that tracking model is extremely important. Okay, so now we see the tracking model is complete, and we can see all those inspection cells as they track with the vial as it goes across the field of view. Over on the right-hand side, you see what are called machine learning curves. So this is the unique feature of Avis. The unsupervised machine learning creates an unbiased model of normal variation, and along the horizontal axis there you can see there's millions and millions of inferences happening. Along the vertical axis you see the number of clusters that are part of that model, and what you want to think of a cluster being is one unique snapshot of normal variation for that particular inspection cell. And so what you see here already, we have 690, 695, 700 clusters that are being added to this model, all different types of normal variation that it's seeing in compliant vials for that particular region of interest. And then each one of those regions of interest has its own unique learning curve and unsupervised machine learning model. All right, so this is the part of the training where we now go get a cup of coffee and we come back later. This takes about 10 minutes. And I'll just skip ahead to that part here in just a moment. In step 3, we're going to take the recipe that we recorded in the previous step, and we're going to use this to process pharmaceutical vials that are just like this one, but different from what was seen in the training. It's important to point out as we get started in this step, and this is a common question that we hear from customers and from my colleagues. They say, since this is unsupervised machine learning, does that mean it's always learning, and how do you qualify a recipe that's always learning? The recipe is not always learning. When we finished step 2, that recipe was frozen and it does not change. The qualification of the recipe is done with defect units and holdback units, just like any other validation that would be done of a computer vision system. And the recipe does not change any further beyond this point. So what we're going to do is we're just going to run some vials through, and I created a recording of this earlier. So I'm going to show what it looks like to pass vials through. Some of these vials are compliant, some have defects on them, and you'll be able to see what it looks like to run a batch of vials through Avis using an existing recording. So click on Start a Batch. We're going to select Start Batch for a pre-recorded recipe. On this screen, what you're seeing is some internal batch numbers, process order numbers. This is customer specific and it's configurable according to whatever your needs are. Okay, so now we've started the batch run and we can see the conveyor moving, we can see the rollers coming through, and now we see the first vial comes through on the P camera. Now the S camera, it's already past the T camera. That first vial, no defect. Okay, here's our first defect. We can see that there's a crack on the S camera. We can see a very large crack on the S camera, and it says gross defect because the Avis, that looks like a very gross defect, a large defect. You can also see in the red marking where to look on the image when a defect comes up into the HMI. Now it's also important to know that these images are being stored in the audit trail, so you can go back after a batch and pull out the vials that were defective and know what the defect was in particular. So I'll start this going again. Here's another defect. This looks like some kind of a scuff up along the neck of the vial. Here's another defect, which is this is a bubble in the glass. So it's very common for molded glass to have bubbles, especially in the neck and the shoulder area, although typically they're very, very small. And one of the things that Avis does, since it's an unsupervised machine learning system, is when it's processing that recording of the compliant vials, it's learning that in the neck and shoulder area, it's okay or it's compliant to have tiny bubbles embedded in the glass. However, this bubble is bigger than what was seen during the recording of the compliant vials, and so Avis calls it out, and this is something that needs to be considered, whether this is an actual defect or not. Here's the next defect that comes through. We see a tiny black speck that Avis has called out as a defect. This one is interesting as well. The powder that is inside the vial tends to clump and cake, and it makes little particle blotches, sort of as it were, inside the vial, and this is why typically humans are needed to inspect this kind of a vial. However, Avis has learned all that. It learns what those types of clumps of powder look like, and so when Avis is seeing this particular one, it's saying this looks different from a clump of powder, and so it calls it out as a defect. I think it's good to point out this would be an extremely difficult problem to solve using a non-AI-based system. Here we have a gross defect. This is just an underfill. Let's see what we have. We have a cap defect over here on the right on the T camera. This is some kind of a splotch or a scrape or a scuff of some kind on the button of the cap. Certainly something that you'd want to see. And that's the last vial as I finish processing those through. This is just to give you an idea of what it looks like to process vials through Avis using a pre-recorded recipe. This is step 3, where you would first be qualifying the recipe for production, and then in production, you should expect the same performance that you saw during qualification.